Hi, my name is Daniel. This is the frequency response challenge video. In this experiment, we track the red object that will be the input of our system, and we are going to then plot and the output response that will be the static the error of the static blue object based on the wall in relation with the center of the image. Here we have the plot we obtain. We can see that at first, at low frequencies, when the red object, when the tracking object moves slow, we see that the amplitude it's bigger for the error of the blue object. That's because as we track the red object very slowly, the amplitude or the camera can keep up to tracking this object, and we can see how the difference between the center of the mass of the blue object and the center of the image is bigger. However, then when the high frequencies start, the amplitude or the error or the output error became smaller. That's because that is when we start moving faster and faster the tracking object, so that the camera can't keep up to the error of the blue object. At the frequency in which the amplitude starts to become smaller is the natural frequency, and we are going to try to calculate approximately at which frequency this amplitude starts to become smaller. Here I have captured more or less the two values between those frequencies, and then I calculate the units or the period in units of time steps, and then I have transformed it into unit of seconds, because we have our time inside the loop for our program were 0.1 seconds. Finally, then I obtain the value of the frequency, that in my case is 0.667, and that, as I said, is the frequency at which the amplitude of the output signal starts to decrease.